I present to you a British World War II navigation system as used on all heavy bombers like the Lancaster, etc. It consists here of the master compass, a VSC, a compensator to put magnetic deviation in. This is the air position indicator, or API. And over here to the right we have the indicator instrument for the pilot. I've put an altimeter and, what more importantly, an airspeed indicator here. Under here is a air mileage unit which is linked to the airspeed indicator and converts the airspeed into a speed of a motor drive for the ASI unit here. Here's another compass repeater. I'll start by switching the master compass back on. It makes a bit of a noise. So now this unit is running up. You will hear the gyroscope run up, and if I turn it, it results in the various instruments from changing. I'll zoom in a little bit to the master indicator here. So if I turn the master compass, you can see that the indicator is nicely turning as well. I built a little automatic system which uses the set point of this instrument to automatically align the master compass with it. So when I switch that on, you can see it's automatically running to, in this case, the west. And there it stays. If I now zoom in on the airspeed indicator, you notice there's a little control which controls the speed of a little air pump. And if I switch that on and it starts running, we will see the airspeed start to run up. And as the airspeed slowly increases, it will automatically switch the air mileage unit on. Here it goes. So this unit is now slowly running, and as I increase the airspeed, you will hear the noise of this little motor drive increase, signaling that it is increasing its speed. So listen out for the air mileage unit. Now it's running almost at its maximum speed, and when it goes slower, it starts sounding a little bit like a two-stroke engine. So we're now running at about 200 knots, and if I now zoom in onto the air position indicator. Okay, let's have a closer look at the API unit, or air position indicator. You can see it's now indicating west, which is the course of the aircraft, and if you look very carefully you will see the west-east counter now slowly count down. It's now at 0 degrees 33 seconds, and since we're flying west, it's counting down to 0 degree and 32 seconds. If I change the course to north, now it slowly adjusts itself. Now this indicator will slow down a little bit, and the north-south indicator here will start to run faster and faster. So north is currently indicating 50 degrees and 4 seconds north, and as we fly further north, you can see that now the second indicator is starting to move faster. So now we're 53 degrees and 5 seconds. Again, if I increase the airspeed, that will result in the air mileage unit running faster, and that will result in the indicators running faster. So you'll hear by the noise that I'm increasing the speed. So now we're running at full speed, and you can see the indicator here is now moving at a fair rate. I'll let it run to the west again, and you can observe how both indicators start to move. The north-south indicator is slowing down, and now the east-west indicator is increasing in speed. Now we've arrived at the new set point in the west, and now this indicator is running at its maximum speed, and the north-south has stopped again. I'll reduce the airspeed again. So that is the running of the ASI. So here's the complete system again. I'll turn further to the south, and now if you observe carefully you will see the master compass actually turn. It's being driven by a small electronic system, slowly turning the master compass, which results in a slow turning of all the indicators, including the one on the ASI.